So yeah, my name is Juan. I'm from Zondax. We do a lot of things in Filecoin, but not just Filecoin, other chains too. But in the scope of Filecoin, we do a bit of like security and cryptography, like ledger integration, like all the infrastructure in the pipeline of Ledger Live. We also do indexing, run some nodes, and do some kind of like services, like for example, coordination with exchanges or supporting like a Lotus team or Philos now. At the same time, we are incubating internal projects. We build and collaborate with other companies, and sometimes we invest in some ideas. So we're more or less around like 25 people, and we're like quite distributed. We have been in the Filecoin ecosystem for around like 4 years already. So like I'm going to do a bit of a different topic, more like kind of a prototyping idea that we have been working in the last few weeks. The trigger problem that initiated all this kind of like prototyping was kind of like this question of like how we can do anomaly detection and alerts, but not at the kind of like networking layer of the chain, but actually at the blockchain level. I mean, in some cases, for example, there are situations where you want to detect like very quickly if there are anomalies at the transaction sizes or like some operations that are happening at the blockchain level or EVM level, and you want to have like this somehow monitor. So, I mean, that was a kind of like a question that we received, but that triggered kind of like some more thinking about this topic. So right now, I mean, the current situation in the Filecoin ecosystem is that we have some indexers. Some are like kind of like going for full archival data that is like kind of long. There are some that are like kind of like more short term or subgraphs. You have explorers, like we have like indexer and explorer called Verix. As we were discussing before, we can provide like a lot of data very quickly. There are some static dashboards where you can like get a kind of like graphic around like, I don't know, the last 7 days or 1 day, but it's kind of like not the same tooling as you would expect like for doing like deep analysis on a security environment. And there are like tooling practices like in general, I mean, in the ecosystem, you have like tools like Grafana, you have like alerting and backend websites like Opgenie, PagerDuty. We have like data analysis Jupyter and some kind of like more advanced security information and event management solutions like Splunk and Datadog. So the thing is, there are things, but there is a kind of like missing link between these two aspects to have a kind of like real-time kind of security tooling. The thing is, real-time streaming data or like getting access to information or like what's going on in the chain like very, very quickly. It's not so easy. I mean, you can somehow rely to subgraphs, but they can provide only a kind of like limited view on what's going on for specific smart contracts. And at the level of like a Filecoin, that is actually not there. And also, aggregation pipelines and post-processing is kind of missing. So, for example, sometimes, like in general, what happens when you have like alerting systems is that you have a situation where you have alerts for a lot of things that people start ignoring immediately because there is missing like correlation. And so this is why Splunk and Datadog CM concepts started to get like better because they can like allow you to have better management of alerting. But the thing is, these things already exist. The main issue or the core thing is where the data is coming from at the really kind of like a low latency and useful data, not just like kind of like totally aggregated data. So the idea was like, okay, can we like prepare some kind of like proof of concept and prototype around that would like tackle these like 4 things, and we started to look at that. So originally from historical data, it's very easy to just like get like really high quality level charting like based on Grafana directly from data that you have like indexed already historically. So you can like drill down and check exactly the point, try to correlate like different points. So that would be kind of like generating historical data metrics so you can find like proper thresholds in the data that you have. And actually, I mean, we have this data at the point where you can see, for example, what is the balance or the amount of transactions, or it's just like this goes directly to a database and you can like get that immediately. So this is kind of like not the kind of like high level snapshot that you can get in standard dashboards, like as many of us already had. I mean, there is a Starboard, there is like Verix, there is Dune that you can get like the fixed kind of like a snapshot, but it's not the same as like having Grafana that most like technical people and security engineers are used to when they need to really find where the point is, where the correlation between two events is, or you can go to the second level or to the weak level and try to understand what are the thresholds for your alerts. There is also the thing about like aggregation pipelines, because if we want to start like doing the aggregation in every database, that means a lot of additional work creating like materialized views and this and that. So you need to have this kind of like aggregation, and also you need to have that as a streaming level. So the idea was, okay, what can we do there? So there are a few solutions. I mean, we started to do this with NATS. libp2p is also an option. Eventually, it could be extended to libp2p. But NATS is a messaging system where you can have like something similar to small packages where you can like group those by subjects, and then you can like have something similar to what would be a multicasting situation, where instead of like having to subscribe to WebSocket asking for the information, like each one of those, you can have like whoever client connects and subscribe to certain events is going to receive that through any point in the network. So it's really like a kind of like peer-to-peer multicasting. We started with NAS because it's a technology that we understand pretty well, but I can imagine that it's easy to move to libp2p. So basically, imagine that you have like some very simple code in Python similar to that, where you can do something and you basically have some kind of like very easy message handler that you can even like prototype maybe in Jupyter in a kind of like a data analysis framework, or you can later productize this and move it to Go. But the thing is, like, you have like a set of like subjects where each of these subjects are coming directly from the network, and it can be like kind of like published. Initially, we did the prototype, we are publishing that ourselves, but you will see this can go like more like community level. You have all these events where for each of the payloads, you have a subject and then you have a payload similar to this. So for example, here, every second you're receiving a lot of those, but you only receive the ones that you subscribe to. So you can filter and you only get that. And it's again, similar to how, it's not identical, but similar to how UDP works. You only get the subjects that you're subscribing to. So you're not like overloading the network. And when the event emitter is like sending the message, it's dropped if no one is subscribing to that. So basically, when you get message like this, you can get the payload and then you can react based on the payload. But the idea is to go a bit further and to look at like aggregation pipelines. So you can get like events from the network. You can process them, aggregate or add additional metadata, and push that data again to the same network, so other people can like start consuming your streams of aggregated or like post-processed data. In that way, for example, imagine that you have something that is trying to analyze data from some contract or some event, and then is sending another event that someone else can find useful. Maybe you find that useful for yourself, or someone else in the network is like doing that. So that goes into kind of like a much more complex scenario where you have like data that is being streamed about, like, for example, a new tip appears, or new transaction going to a certain contract, or some balance is going over a certain threshold. And then you can start emitting events for that, like that everyone else can consume. And those can go into a sink where you, for example, can store that into a chart, or you can put that into the database, or it can trigger an alert. So in a way, now we have a kind of like network of streaming messages and subjects that is efficient, because if no one hears that, you don't need to store and it's like lost. But if someone is subscribing to that kind of message, you can collect that. And actually, you can even like store them and like replay eventually if someone wants to see how the thing was like 4 days ago. So the thing is, how is this is useful? Because the thing is, if you have like real-time data alone, is very good for alerting, but you don't know where the threshold for your alerts are. So you also need the historical data, and combining these two things with standard tooling instead of like kind of going and reveal everything again. It's okay for users when you need to have like very user-friendly user interface, but for technical people, maybe Grafana is a much better option, or it can be Kibana or anything like. But let's not reinvent the wheel. So. Journey ahead, the idea, okay, we are starting to look at if this kind of like concept is good. We are like looking at this in a multi-chain environment where you can even run like even correlation and subject in different environments. So you maybe try to find what is the relation between this network and another, how Filecoin is interacting with Ethereum or stuff like that. We are trying to standardize the subject schema, so there is a kind of like concept behind that is much more like predictable. And the idea is to prepare like some examples of what I've shown for correlation, processing, and syncing. So you can have this pipeline that I described before, kind of like easy. And actually, this is a much kind of like higher level concept, because like Filecoin is mostly about like storing bunch of data over time. But what we are talking here is about creating a kind of like environment or ecosystem of third-party streams and event processors that they can like consume or not. And at some point, you can like even get like encrypted streams. So some people can like subscribe to some streams, but if they get the decryption key through some like payment channel or something like that, they can like consume that. Yeah. So this means we are starting to consider like things like, okay, how about reputation? Because some subjects can come from someone that is not like with the same reputation as the other. So then you can, maybe you want to consume like 4 streams or the same kind of data set, but you're like want to consume that from different sources. Or for example, there is a stream that someone is publishing mempool, but you have like now mempools from different places in the world, and you want to consume the data from the mempool in like Asia and the data from the mempool in the US. So reputation is another topic, and then like going multi-chain. So overall, this is kind of like different concept that we're starting to explore, moving from kind of like fixed data to streaming data in channels and subscriptions. But yeah, basically have fun, more ideas, and try to innovate a bit on the topic, especially to address the original question. But we think that this is not just addressing that, but addressing many other questions. And yep, that's very quick, kind of like summary of what we have been doing this year. Obviously, you can follow us, or you can also kind of like contact us for like standard data, like for example what I was discussing with Miro before. I mean, my understanding, unless there are changes, is that they are kind of like using a lot of Verix. We have an API that provides all the information for historical data. For archival nodes, we have also RPCs. If you want to consume data that is not like really available, like the last 2,000 blocks, we normally have like archival nodes that are like, I don't know, 50 terabytes of storage that they have all the kind of like historical data. So, yep. Happy to get any questions if there is time. Otherwise, coffee outside.
No. We have 3 more minutes. Questions.
Thanks for sharing and explaining. If you could direct developer resources in this vision, what do you ultimately hope to see with this loosely coupled event pub sub system? Like, what would you like to see happen out of all this work?
So, I mean, from the point of view of security, we have been like kind of in touch with people from Filecoin Foundation, because they have that problem like today. They need to have a way to react to kind of like events. So, for example, one event would be like a Steve like a few months ago, or like a year already, where suddenly someone is like moving a huge amount of funds from one place to the other, and then you want to have a kind of like clear overview, or there is like some network saturation, and then you want to see why the spike is happening, and then you really, in the moment where you see a spike in gas, you can go to some like place or dashboard, and then you can do an analysis like on the spot, in a way that if you know how to do some data analysis or use Python, you can even drill down to exactly the point and try to do the analysis. These kind of like fast reaction times are what like normally like fixed dashboards are not there. With respect to kind of like getting something from kind of like the whole environment that would help us, at the moment, like the main issue that we had been like for a really, really long time, like Lotus stability with respect to kind of like RPCs, like response times. That has been kind of like quite complicated over time. But now things are getting better, and we have like an internal solution to overcome that. But in general, it has been like mostly, I mean, and to be honest, it's not that there is a problem there. It's just that that's our most common interface. Is what I can say we have more interaction with. But yeah, those points are kind of major pain points from the kind of work that we do.
So you're talking a lot about, for obvious reasons, we're talking a lot about data, but I guess, what do you see as the way people are going to be using this information? Sorry? So what do you see as the kind of information that people want to use on this?
In this case, with this? Yeah. Well, I mean, like people can get any information. So basically, there are situations where, for example, you might, instead of like getting check on an RPC, you can get directly a subscription, and then you can like rebroadcast that to all the nodes that have the interest in that specific thing. So this kind of like puts you away from kind of like daily interaction, or even like creating WebSockets like everywhere. That can be like quite complicated. I mean, that drives a lot. I mean, typically egress in cloud providers is like killing everyone that is like getting a lot of like, I mean, RPCs are costly, not just because of the RPC, also because of the load that you put on egress. But over time, the idea and what I was like kind of like pointing here is this was more kind of like designed to solve the problem of observability and security, but we see that this can like move to anything else. Like actually you have a network of streaming information where you can like correlate that information or mix them, and then you can do anything that actually you want. It would be like kind of like a web RTC of any kind of like blockchain data, or not even not blockchain. So it's more like tooling for people to use rather than kind of like we are like targeting in this specific proof of concept level the use case, right?